Hi, I'm Chris Reutlinger.
And I'm David Altfeld, and today we're going to talk to you a little bit about wind loads. A lot of people think maybe the weight of our panels are the controlling factor in our design, but really the wind load is usually what's controlling our design. And wind sometimes causes things to behave in unexpected ways. So there are four main factors that affect the wind load. These are all from the building code, and they are surrounding buildings and terrain. You can imagine that a building on a lake would have different wind effects than one in the middle of a city. And risk is another one. You can imagine that we would design a hospital a little bit differently than we would a grain silo.
Yeah, and so the other two factors are location and height. Location being where they are, mostly in relation to the coast. So buildings that are on the coast where hurricanes are more prevalent usually have higher design wind loads than something that's inland. And then height is actually a really big factor in determining the magnitude of the wind loads that we have to design for. So most people would think a building in Miami would never have, or would have much higher wind loads than we would have in a building in Atlanta. And sometimes that's not true. We have 400 feet tall buildings here in Atlanta that have much higher design wind loads than, say, a 30 or 40 foot tall building in Miami. The other misnomer that I think occurs when people think about wind design is that a building, or a panel or a component that's at the bottom of the building actually has a much lower design pressure than at the top of the building. And that's actually not true. And the reason why is the building code mandates that we actually design for the suction on the back of the building. So when wind hits a building, you have some positive pressure pushing those panels or pushing that facade into the building. But as that wind goes around, these vortices actually, and turbulence get created that cause a suction on the back. And that's constant all the way up and down the height of the building. And so no matter where that panel or component is in elevation of the building, it's going to be designed for that same wind pressure. So I talked a little bit earlier about how this turbulence actually causes suction on buildings. You'll see in this video, it's actually a plan view that shows the wind sort of coming around the building and creating that turbulence or those eddies on the back end that causes that suction.
You can see the buildings on the left are blocking the wind from the building on the right, sort of shielding the building on the right from the wind. Another approach to determining the wind loads is to do a wind tunnel study. In a wind tunnel study, a model is built of the building that we're designing and also of the surrounding buildings, and it's put in a wind tunnel and rotated, and then there are sensors on the building to determine the pressure at every angle of the wind.
And when a wind tunnel study is done, actually the design pressures are generally lower than what we get from the building code. It also gives us some more detailed results. So if there's some areas that are sort of hot spots that have higher pressures or areas that have really lower pressures, we can tailor our design for those specific areas by doing that wind tunnel study. So there you have it. It's a brief overview of wind and how it affects buildings in our panel design. I hope you enjoyed it. Hope you'll join us next time.